Welcome my dear students. I am really happy to see you all in my channel. Right, my channel name is Physics with Ramseen. I will continuously upload physics hard questions in English medium and Tamil medium continuously. So keep connected and share with the English medium students and also Tamil medium students. I will continuously upload hereafter most of the hard questions in the physics syllabus. Right, and also I hope you all have seen the question and go through the question very carefully because I have attached the question in the beginning of the video. Right, first you have to push the video and read the question carefully and try to solve. Right, okay. First I draw the diagram and the picture given in the question. Right, there is a vehicle in the question. So first I draw. There is a vehicle in the question. Right, here it shows the something like a balloon and the liquid, and that is the vehicle, and also the velocity time diagram also given. Right, this is the T1 duration, T2 duration, T3 duration. This is the time velocity. Right, let's move on to the question and read the question carefully. This is the 2020 question, 35th MCQ. Right, consider a massless balloon. Consider a massless balloon attached to an end of a light string. Light string means it has no mass value. The other end of the string is attached to the bottom of the water tank. This liquid is water. They have given water tank which is fixed in a truck as shown in the figure. There is a balloon. There is a balloon. Massless balloon. Here we take massless balloon attached with the string also light string, so it also has no mass values, and attached in the track. Right, the balloon is completely submerged in the water. Here we can see the balloon is submerged totally, and the velocity time graph shows the motion of the truck. When we analyze the velocity time diagram, first we can understood the velocity at the initial time is 0. So I can say the initial velocity of the truck is 0. And also when time passes within the time duration T1, the velocity increases. You can easily find out that the velocity increases with the same gradient and also the same slope with time. Right, and also afterwards within the T2 duration the velocity will not change, doesn't change, and also after the T3 duration time duration the velocity reduces. That I can find out through the velocity time diagram. So why is this velocity increasing happens? Because of the acceleration is acting on the same direction. Same direction means the forward direction. And also after T1 time, first of all the force or the acceleration acting on a track is forward direction, and also in the T2 time we can find out that there is no velocity changes within the time duration T2. So I can say within this T2 time duration there is no acceleration I can find out. So there is no external force also, because F equal ma in this Newton's second law, we can say the mass and the acceleration multiplied is equals to the resultant force. When the acceleration is in the body, then I can say the resultant force acting on the body. Right, but in this diagram, within the time duration t2, there is no acceleration in this time. So I can say mass multiply by acceleration is equal to 0. There is no external forces. And also after time goes, the time duration t3, I can find out that the velocity reduces to 0. I choose that the maximum velocity is equals to v naught. First 0 to v naught, and also v naught remaining, and finally v naught to 0, the velocity goes, right? So I can find out the velocity reduces. So the acceleration is acting in the opposite direction. That's why the velocity value is going to reach the 0 value. So in this time also, the resultant force is also acting on the same direction of the acceleration, right? These are the analyses that we have got from the velocity time diagram. Okay, right. So I can say first time t1 duration, there is a resultant force or the acceleration acting on the forward direction, and also within the time duration t2, there is no external forces or any accelerations in the time period. And also within the time duration t3, there is a resultant force and also the acceleration acting on the opposite direction of the track moves, right? That's the analysis that I have come from this velocity time diagram. The question is the position of the balloon and the string inside the water tank during the timed interval t1, t2, t3 are best represented by. That's the question, right? What's the question? When the track moves with accordance with the velocity time diagram, then what will happen in the position? What will happen in the position of the balloon? Right. That's the question. Right. First we have to know. I'm going to explain some similar examples, but we can easily see in our environment. Have you seen and have you felt like this? When you are in a bus, you are freely sitting on a chair. Okay. Then suddenly the bus accelerate. Then you are going to collide with the back side of the chair and make the reaction force on the direction of the acceleration of the bus. What will happen? Why it comes? Because and also same things we can say. There is a mass attached with the string is attached with the ceiling. Then the ceiling and also ceiling goes with the acceleration in a given direction. Then what will happen? When the ceiling moves in this direction with the given acceleration, then also the mass value also need to be accelerated with the given direction. So that's why I can say this position moves to this direction, and also the tension T and also the weight mg. Then this is the angle of the tension, right? Then I can say T cos theta is balances. T cos theta balances mg, because there is no acceleration in the vertical direction, and also there is a horizontal acceleration A. It also need to be accelerated in the mass. So I can say when we consider the free body diagram, mg is acting on the body in the vertically downward direction, and also the tension T is acting with the direction of theta. then I can say t cos theta. When we consider the vertical direction, t cos theta balances the weight of the mass, and also when we consider the horizontal direction, t sin theta will not be balances with any forces, because there is no forces acting on the body, because already balances the weight. Then t sin theta is the horizontal resultant force acting on the mass is equals to m into a. M into a is the resultant force is equals to mass multiplied by the acceleration, right? So I can say right, so I can say this is the acceleration. So t sin theta is equals to m into a is equals to t sin theta over m. Then I can find out, that's the reason the position of the mass is comes to this position, because the t sin theta value is the resultant force. So the resultant force should be acting on the body with the given direction. That's why the position comes to this this one. When if you think the position comes to this direction, what will happen? The t cos theta value balances the weight of the mass, and also t sin theta value is the resultant force acting on the mass, but the opposite direction of the acceleration of the ceiling. So it will not, it will never happen like this. That's why the position moves this direction. Have you seen like this? When a ceiling moves this direction in acceleration a with a given direction, but the mass is remaining in the same position. Is it possible to move? No, because when the mass is like this, then the weight and the tension of the string also vertical forces, right? Those two are vertical forces. There is no horizontal forces acting on the body. Then how can the mass accelerate with the acceleration a in a horizontal direction? It's not possible. So that's the reason the mass comes to this position. And also that's the reason when you are sitting on a bus, the bus driver accelerate the bus, then you are collide with the backside seat and make the sudden reaction force and getting a same acceleration, and also suddenly you get the resultant force horizontally and getting the same acceleration in the body, on the body that the bus moves, right? So these are the things I have told. When you are sitting on a bus like this, there is no acceleration. When the bus accelerates, then you are going to be like this. You are collide with the back side of the seat. Try to understand what's happening. When you are collide with this this back side of the sheet, then the reaction force acting on the horizontal direction in the acceleration side. Then there is a resultant force and also the acceleration. You have got what the bus already moves, right? That's the reason. So in these two diagrams and the two situations, I can easily find out that when a ceiling moves or the bus moves in a direction, then the mass comes to this position to getting the same acceleration value. When a bus moves with the direction given and also the acceleration a, due to that it also comes to this position and get the acceleration value. So finally it always get the same value that the bus moves, also the ceiling moves, right? It doesn't matter, but the position changes. According to getting the acceleration value that the bus or ceiling moves, right? So when we consider the position, what is going to happen, right? When the ceiling moves with the direction of here, I wrote the direction. but the position is coming backward direction, opposite direction of the acceleration of the ceiling. And also when the bus moves this direction, and also the position changes with the opposite direction of the bus moves, right? That's the reason both two are similar examples that we have already felt and also already seen in our environment. It's always happening, right? So what's the reason? What's the reason behind this? When a body moves, all the particles are getting the same. When a body moves with the particular acceleration or the particular value, so the particle of all the bodies are going to get the same acceleration value. But it doesn't matter. It's always happening. But the position changes. What the position change? Opposite the direction. Here also the acceleration this direction, the position changes of the particle or the man is opposite direction. So opposite direction they have got. So I can say you have always seen the all the environment examples are you have already known that the density of the air mostly around 1.2 kilogram meter minus 3, right? 1.2 kilogram meter minus 3. And also you have seen all the things in the environment is always higher than the density of the air density. When you are seeing a person, when you are looking at mass, when you are looking at any particular things which is maybe a chair, table, fan, etc., all the things are made with a particular specific density value that is always greater than the air density, right? We are in the air. Air is always a fluid. Then there is a fluid also always, and also the air is consists of very low density, and also we can analyze the particles, whatever the things are, and also the man or human or animals, whatever, all the things are made from the material density is higher than the air. So there is a theory behind this. What's the theory? The theory is when a body moves, all the particles are getting the same velocity and the same acceleration at a given time. That's the theory. But the reason when we get the same, if you want to get the same acceleration and the velocity, the position should be changes, right? Without changing, we can't get the same acceleration or the same velocity at a given time. So the position should be changed, but the changes position direction is opposite the acceleration. That's the analysis that we have got, and also that we have analyzed and that we have already looked and felt, right? Okay. So the theory is what's the theory behind this? When you think a subject, when you think like this, and also a particle like this, when a body moves with a given direction acceleration, also it should be get the same acceleration value. That's the theory. But we have to check the environment density. When we are in a world, so the environment should be surrounded with the air. So environment density is always air density. Environment density, I choose rho E. Environment density is always air density. Air density is very low, 1.2 kilogram meter minus 3. And also we have to check the particle that is going to get the same acceleration of the body, right? The particle is mass. Here is the mass particle. Here is the man, human is the particle, right? Okay, human or the human or masses are, it doesn't matter. All the materials are, we have looked in our environment is greater higher density than air or environment density. So when the density of the particular particle or any other things, right, the density of the particle or anything, right, objects greater than environment density, then when a body moves with a given acceleration, with a given direction, and also it will always getting the particle always getting the equal value. That's not a case. But this condition, when the environment density is less than the object density or the particle density, then the position moves with the opposite direction of the object or the opposite direction of the acceleration, right? Opposite direction of the acceleration direction, right? And also when we are going to check the another example, that is environment density is greater than the object density. Environment density or the whatever the fluid density surrounded the particle is greater than the object density. When the object density is greater than the object density is less than the environment density, what will happen? Always the object density is equals to environment density, or the object density is greater than the higher than the environment density, or object density is lesser than the environment density. It doesn't matter, but always when a particle getting the same acceleration or the same velocity at a given time, it doesn't matter, but the position changes is always differ from the according to the density changes. We have already checked that the environment density is lesser than the particle density, then the position changes with the position change what? The acceleration, opposite direction of the acceleration. When the bus moves this direction, and also the position of the particle moves the opposite direction and get the same acceleration value. When the ceiling moves this direction, and also the acceleration direction is like this, and also the particle moves opposite direction of the acceleration. So these two examples we have already explained, right? These are the examples for what? Environment density is lesser than the particle or object density. Then it was fine, right? Then when we check these things, environment density is higher than the object density. When we are going to look this diagram, the question given, the balloon is submerged in the water. The water density is 1000 kilogram meter minus 3, and also it's the massless balloon. Then there is a air in the balloon. The air density is 1.2 kilogram meter minus 3. Then I can say surrounding or environment density. Here surrounding or environment is water. Then the object or particle is air. So here environment is water. Water density 1000 kilogram meter minus 3, and also object or particle density is 1.2 kilogram meter minus 3. Then I can say object density is lesser than the environment density. What will happen? The particle always getting the same acceleration at a given direction, but the position, what will happen with the according with the these condition? The position changes opposite. That means when the object density is higher than the environment density, that we have already explained, that we have already analyzed, what will happen? When the body moves, the particle comes to the opposite direction and get the same value, acceleration value. But this condition, what means? The environmental density is lesser than the, environmental density is higher than the object density. What will happen is, it also getting the same acceleration and also same velocity at a given time, but the position changes when the body moves. The particle always getting the same value, but the position is need to be changed to get the same value of the body. So the position changes. Here opposite direction, the position changing direction. Here same direction. what will happen when the body moves like this, this is the acceleration direction, then the particle always changes the direction to getting the same acceleration and the same velocity at a given time. So the position moves here, this condition. According to this condition, the position moves with the same direction of the body acceleration. But here, opposite direction of the body acceleration. Here, same direction of the acceleration. The position changes. That's the theory behind this. There is analysis and also derivation methods also available, but there is no needness for physics, because they will not check how the theory comes. They are only checking the these these questions, not the derivation methods or anything. They will not check and they will not analyze, right? So you have to get the idea and the theory behind this. Why it's happening? It's okay. You are going to get the output of the analysis, right? No need of derivations, right? So we have to check the question. First of all, we have already determined the track is moving the with this direction, and also within the time duration t2 there is no acceleration, and t3 time there is an acceleration opposite the track moves, right? So I can already find out that the here water is the environment and also the air is the particle. Then the environment density is higher than the particle density. What will happen? The always getting the same acceleration value, but the position changes same direction of the acceleration. That's the sceneries within according with this the condition, right? So first of all, we have to check the acceleration direction is here. So first of all, we need to know acceleration is like this. So first of all, the position of the balloon is like this in a vertical direction. Then the acceleration direction is right direction. So I have already determined with the according with the velocity time diagram. So I can say the position changes same direction as the body acceleration. And also this is the t1 time duration, and t2 time duration there is no acceleration. Means there is no horizontal acceleration, so there is no needness for position changing for with the given time t2. And also the third one, t3 is the given time duration. Here we have already determined that the acceleration is opposite direction of the track moves. So here the acceleration direction is like this. So it already in a vertical direction, and also the acceleration is like this. So position need to be changed with the acceleration direction. According to the environmental condition. What is environmental density is higher than the object density. That's the or the particle density, like this. According to this scenario, we can find out these things. Okay, right? When you check the answers, what is going to be the answer? I think fourth answer is correct, right? Okay.